So number 2 is asking you to find a power series for f of x centered at 0. And it gives you a function x over 1 minus 2x cubed. So let's go ahead and let's see if we can find a power series associated with that. So we know that the form our power series usually takes is the summation of n equals 0 to infinity of x to the n, and that is derived from the function 1 over 1 minus x. So we know that if we can get our function in that kind of form, we can find a power series associated with it. So in this case, we're pretty close actually. The only thing that's kind of setting us off a little bit is this x term up here. But what I'm going to do is I'm just going to pull that x out in the meantime, and I end up with 1 over 1 minus 2x cubed. So now we have 1 over 1 minus some function of x. So now this function of x, I can raise it to an n power in a power series. So let's go ahead and let's do that. So I have x on the outside still, but now this term in parentheses becomes the power series of 2x cubed to the n. Okay, good. So we can simplify this a little bit, and let's go ahead and do that just for good nomenclature. So we have n equals 0 to infinity. I end up with a 2 to the n, x to the 3n, and this x term out here is to a first power, so x to the 3n times x to the 1 will give me x to the 3n plus 1. Good. So we have our power series, but we're not done yet. So in the problem, it actually gives us this series twice, but with different radius of convergence. So what we need to also do is we need to find the radius of convergence that satisfies this series. So let's go ahead and apply ratio test one more time, and let's see if we can figure it out. So we have the limit as n approaches infinity of a sub n plus 1 divided by a sub n, and that's equal to limit as n approaches infinity of, my a sub n plus 1 in this case is going to be 2 to the n plus 1, x to the 3n plus 4. So if I plug in an n plus 1 term, 3n plus 3 plus 1 gets me x to the 3n plus 4. Divided by a sub n, which is just 2 to the n, x to the 3n plus 1. Good. So we can go through, we can simplify some stuff. So we end up with an extra 2 on top, and here we have x to the 3rd. So the 3n's would cancel, we'd be left with an x to the 4th divided by x, which would leave us with an x 3rd on top. So according to this, according to ratio test, this term has to be less than 1 for it to be convergent. So if I isolate what I ended up with, I need to figure out what x value will satisfy this term. So what I'm going to do is I'm going to divide the 2 over and try to get x to a single power with a 1 coefficient. When that happens, that is my radius of convergence. So if I tried to declare my radius of convergence now, I would actually be incorrect. X has to be to a 1 coefficient and to a first power before you can declare radius of convergence. However, if it's added or subtracted, that's okay. That you can split when you turn into your interval of convergence. But for now, if I divide the 2 over, I end up with x cubed is less than 1/2. And if I take the 3rd root of this term, I end up with x, absolute value, is less than 1 over 2 to the 1 over 3. So 1 to the 1 over 3 is just 1, and 2 to the 1/3 is a decimal, but we'll just leave it in that form because that's actually what the answer leaves it in. And this radius corresponds to answer C on exam 3B.
The Teaching Center, UF's Learning Resource Center.